Welcome to our AI for Everyone instructional video series. This instructional video series is developed by the American Institute for Professional Training and Development, a nonprofit organization. This educational video series is designed to provide an opportunity to learn about AI and explore how to benefit from this remarkable technology. The entire series is available for anyone to view at no charge. My name is Sandy, and I will be the AI avatar guiding you throughout this presentation. Every time you type a message to Claude, ChatGPT, or any AI assistant, something happens before the model reads a single word. Your text gets converted into tokens. This presentation is about that conversion, what tokens are, why they matter, and how understanding them helps to makes you smarter when working with AI. When you read the word unbelievable, you see one unit. Your brain processes it instantly as a whole. A large language model doesn't do that. It breaks unbelievable into three parts. Un as one part, believe as another, and obel as a third part. These three parts are three tokens for the AI. The word transformation becomes two parts, transform as one part and ation as another. The term AI stays as just one single token. Why does this happen, you might ask? The answer is actually quite simple. It is because LLMs were trained on a vocabulary of subword units, not whole words. Rare or long words that didn't appear often enough in training data get split into their component parts. Common words get a single token all to themselves. This isn't a limitation. It's a design choice that lets the model handle any word in any language without needing an infinitely large dictionary. Now let's zoom all the way in on a single token. Meet the word Paris. Token number 4225. The surface text is what you see. One token might be a full word like Paris or part of a word like un. It could also be a space or even a punctuation mark. Every token in the vocabulary has a unique integer ID. The model never actually sees the letters P, P, A, R, I, S. It only sees the number 4225. Then that number maps to an embedding, a list of roughly 1,500 floating point numbers that encode the meaning, the grammatical role, and relationships of this token to all other tokens. That vector is what the transformer processes. One more thing worth noting, the meaning of Paris isn't fixed. Its embedding will shift depending on context. Paris in a geography question carries a different weight than Paris in a fashion article. The model tracks these differences through attention. A token is like a poker chip. The chip itself isn't money, it's just a placeholder. What matters most is the value assigned to it and how it's used in the game. The tokenizer is the component that splits text into tokens. It follows a simple rule. Frequency wins. If a word appears often enough in the training corpus that it gets its own vocabulary entry, it becomes one token. Common English words like the and Paris are all one token each. Less common words get split at recognizable subword boundaries. Unbelievable becomes unbelievable, three separate tokens that are all common enough to have their own entries. Rarely used words or technical terms get fragmented further. A word like chrysanthemum might split into 5 or 6 tiny pieces, each just a few characters. Think of it like a spell checker that has a dictionary of known words and syllables. If your word is in the dictionary, great, you get one entry. If not, it breaks it up into the pieces it knows and recognizes. That's it in a nutshell. Now let's take a look at the practical numbers that affect your everyday AI use. First, we will look at the API cost. Most AI APIs charge per token, not per word, not per character, not per message. At $3 per million input tokens, a 1,000 token request is about a 750 word prompt and costs roughly 0.3 of a cent. It may seem small, but you would be surprised how quickly it adds up at scale. Let's now talk about the context window capacity. Claude 3.5 can hold up to 200,000 tokens in its working memory all at once. That's roughly 150,000 words, which is about 500 pages of text. Earlier models had only 4,000 token capacity. The growth has been exponential. The other item we should also address is the conversion factor from words to tokens. English language averages about 0.75 words per token, so 1,000 words becomes roughly 1,333 tokens. But here's where it gets interesting. Non-English languages are less efficient. 1,000 Chinese words can become 2,500 tokens, costing more and consuming more context. On the other hand, a coding language tends to be more efficient. Common coding keywords and patterns often occupy just one token each. Here are 6 things about tokens that will probably surprise you. Even experienced AI users are often surprised by them. First of all, you need to know that spaces matter. The words dog and dog with a leading space are different tokens with different IDs and different embeddings. Now for the second surprise, numbers split strangely. The year 2024 is 4 tokens, 1 per digit. Large numbers fragment completely, which is partly why LLMs are unreliable at precise arithmetic without a calculator tool. Another surprise is that non-English languages are expensive. Most tokenizers were trained on predominantly English data. As a result, languages like Japanese or Arabic use far more tokens for the same amount of information. Here is one more surprise for you. Code is efficient. Common programming keywords are often just single tokens, which is why LLMs handle code remarkably well. Now it's time for our 5th surprise. Capitalization in any word adds to the token count. Paris, with a capital P and lowercase letters, is different from the word Paris, with all lowercase letters, and naturally, Paris in all caps may also map to different token IDs, even though in all 3 cases we are looking at the same exact word. We are now ready for our 6th and final surprise. Emojis are token heavy. Simple emojis are 1 token. Flag emojis and complex combinations will usually use multiple tokens. Well, is it for token surprises. So what does all this mean for you now? Let's see if we can connect all this to some practical decisions. If you have a long prompt that gets cut off, you've hit the context window limits. Every token in your system prompt, conversation history, and current message counts against that limit. So it is always helpful to trim unnecessary text in your prompts. Be as concise as possible. If the model makes arithmetic errors, keep in mind that it only sees token IDs and not numbers. 1, 2, 3, 4, 5, 6, 7 are 7 separate tokens. Precise math calculations require a code tool, not raw language generation. If you're going to be using AI across multiple languages, budget extra tokens for non-English prompts, as they cost more and consume more of your context window. And when pricing or planning AI at scale, think in terms of tokens, not words. Roughly speaking, 750 English words equals approximately 1,000 tokens. That's a helpful conversion to keep in mind. Now for our 3 takeaways. Number 1, a token is the atomic unit of LLM text, a subword chunk that maps to a numeric ID and then to an embedding vector encoding meaning. Number 2, tokens are the unit of both cost and capacity. APIs charge per token, and context windows are measured in tokens. And number 3, tokenization has surprising edge cases, like spaces before and after words, capitalization in a word, numbers, and non-English text, all of which behave in ways that explain what otherwise may seem like mysterious LLM behavior. Thank you for watching. I look forward to having you join me in our next video presentation, where we will discuss AI versus human intelligence. We will explain how artificial intelligence compares to human capabilities, the distinct advantages of each, and why collaboration often yields the best outcomes.